Okay. Hello, everyone. Welcome to the wasmCloud community meeting for Wednesday, May the 8th. Today, we've got a couple of demos and then a discussion item at the end of the roadmap. But it's going to be pretty much all about Go today. So it should be a pretty fun meeting. To start, we have a demo from Roman who's talking about WRPC, aka WIT RPC, and the Go implementation, which he kind of started off showing off with our hackathon community meeting. But Roman has even more to show you now. So, Roman, go ahead.
All right, thank you. Let me share my screen. Okay. All right. So this week I've been busy working on actually a with Python WebPC generated for Go. So it's with binding generator for WebPC for Go, right?
Hey, Roman.
Um, oh yeah.
Sorry, I don't know why it says that you started screen sharing, but it doesn't come across. Is that just me, or is that other folks too?
Yeah. Huh, just worked.
Seeing the
By
same
the way,
problem.
Primer.
There we go. Looks good. Also, mm, well, I can't hear you now.
I'm sorry, I was muted. Okay. All right. This now it should be good. Okay, cool. So this week I've been working on with Bindgen RPC, in particular Go support for that. So bindings for with RPC native application bindings for Go. Um, so I have a simple example here. Show this terminal here. Let's look at some Go examples here. So let's start with something very simple. It's going to be just, hello world example here. So I have, simple hello world kind of package, which has a client world, a server world, and I'll have like Go service then actually serving the server world, and having this hello function exposed on with RPC. So I'll start off with well, I have this nice directory here. I'm going to remove the bindings just to show, that I'm not cheating and let's write these bindings by hand. I have this hello server file here, which has a line which will be familiar to Go developers, which is like just directive for Go to enable Go generate functionality. And this is just, it's just here just to run my Bitbucket RPC from the repository itself. But this is really the command line that we care about here, right? So this is calling with Bitbucket with RPC, just like Go as the language to generate. It's like the output directory. And one extra thing I have to do here is set the package in which these bindings are going to be located, and that's for bindings basically to be able to refer to. So just how Go imports work. So I need that's one only little thing I actually need here to specify to actually do that. So now with this, I can just do Go generate. As you can see, I have these two files generated. Right, my tree, and again, I finally have these bindings here. So now I can run my hello server NAT. And let's see if I can. I'll just call it from Rust in this case. I'm not going to show you those Rust source code or anything else. But hello, what is this? NAT line. Now I'm going to run it. Run go. Yeah. And so I get the hello from Go, and that hello from Go came from implementation of the generated bindings right here. So I construct a NAT client over here with the Go prefix. So I'm listening on Go prefix on my WebAssembly topic. And then I just call serve from the server I've imported from my bindings right here. And the serve is the name of the world that I'm actually generating bindings for. So I just serve it with a handler. And finally, the handler then has the hello function, which like a very Go-esque kind of API here, which take a context in, just like general Go, say HTTP services that normally do that, right? And so I even use log just to log my request and I return a string. So again, if I just run, yeah, well, you can see I can just call the things I want and I get my hello. We can actually do something. We can actually do something more interesting, and we can try to serve key value. Again, the interface is fine here. Well, not even look at that. But yeah, it's just WebAssembly key value store interface. Um, and then I'm going to have a simple in-memory hash map implementation here, which is going to have this general normal CRUD that deletes and exists and gets and all these all the normal key value things. And so to call it again, I can of course call it from Rust using my WASI. I'll usually use a component which will call this thing. So I'll do something different here. I'm going to run wasn't time. Right. I need to do this. There we go. I need to run it first. Here we go. So what happened is that my components in Rust, get that. Let's do this one. It opened some example bucket. It set foo to bar. Now it checked that foo indeed exists after it was created. It tried to get it. It checked the value of that, and then it printed the keys in my bucket. So again, I can run this more times and see if it works. And similarly, I can actually have I can use functionality which is recently added to WebAssembly project. Actually, is to just directly invoke some functionality from defining width. So, for example, I want to use key value store interface. I want to call store together, store set. So I can just do it from CLI directly, right? I'm going to specify again the prefix of Go, where my Go application is listening. I can try to just get my foo, right? And so what this actually does is actually it is, but it would work for any implementation, right? Of WASI, well, with RPC key value, right? So if you had the Redis behind this, or you had memory store or anything else, if it implements with RPC key value, I can actually use the CLI now to query it using, the functionality defined in width, right? Let me try to list keys, for example. Just see, here we go. We have real response here. If I try something, it doesn't exist, of course I get nothing there, right? So it's not a setup that actually works. Yeah, so that is for now support will go with RPC. What we have right now is support for serving with. We support everything except for signed ins, flags, resources, futures, and streams. And by the end of this week, I plan to have all the sync, so the signed ins and flags, and then resources and async is going to be next. But yeah, so I think, and also like the client bindings, that's also going to be probably later. For now, it's really just serving stuff of so capability providers which expose functionality but not call other anything else or use RPC. So yeah, that's my now.
I just decided to do it with the proper uh uh whatever proper procedure before getting too excited. Um Roman, was that WRPC key value nats binary? Is that something new that you added, or have you had that for a little while? Just like being able to invoke specific functions, just in a nice way.
Yeah, no, I just did it yesterday. Yeah. It's very, very, very simple wrapper for it's just basically use with binding with RPC and Rust to generate the bindings for the interface and just wraps it and it's very simple CLI to call it from CLI.
Awesome. I would like to steal it. I would like for that. That would be really cool to have in Wash too, like for our Wash call. Like that, it's like exactly what I want to be able to call that specific function. That's awesome.
Thanks.
So we basically just saw a great way to extend WASM time with plugins, right, over RPC. We just saw an amazing way to be able to just take a component, introspect it, and be able to talk to it generically anywhere with cool things like the CLI that Roman made. What else did we see? We saw a bunch of stuff that I'm pretty excited about. And Roman, actually, I saw this demo an hour ago in the component model biweekly meeting that we have in the Bytecode Alliance. So I'm super excited about it there, and everybody seemed to be in favor of us donating it to the Bytecode Alliance. So I think we'll be seeing this as like a fundamental layer in just about everybody's stacks going forward. It's huge.
Yeah, I was just gonna say that like just the process of what you laid out, much like what Brooks laid out, with the WIT web page using Jco. What was that last week? 2 weeks ago? Just that workflow is so different from anything else, right? And so I think we really just if we I'm sure like everything should be documented, but that really needs to be kind of. It's not something that if you just had like if you really knew Rust or really knew web development or really knew server-side development, that would just be intuitive to you, right? It's just such a novel concept that we really have to make sure, or I would suggest we really document the heck out of how to do that because it's just so different. And it's awesome.
Yeah, I think that's. Oh yeah, go ahead, Roman.
So yeah, I just wanted to say that I think so. I've been working. I was a Go developer before, and so actually I used a lot of gRPC. And so this concept of like having to generate bindings using Protoc, like had to first install Protoc compiler, then you had some Protoc plugins in your path, and then you would be able to generate bindings say for Go for gRPC service from the Protos. And then so that concept I think is should be quite familiar. But certainly, yeah, there was quite a few different things here with the how it works.
That's true.
But,
If you have a background in gRPC, WRPC will probably make more sense. I don't, so for me, it's all just seems to be magic. But yeah.
That's funny. I was actually gonna say a really similar thing. I went diving into the gRPC intro, like quick start things to find some inspiration. Like this is a really similar model. How can we do it? Can we do things with less friction than gRPC says? And I think that they obviously gRPC has pretty wide adoption. So the way that they explain things and get benefits across is something that we should take inspiration from, aka document the heck out of it.
I mean, I'm just throwing that out there. I'm just slow. I'm just slow to pick it up.
No, I think it's not that at all. I mean, I think it's important that, that we, restate, the whole process end to end again, what we're doing here, because there are a lot of concepts that are coming at people here at once. And, we really need to understand that, the machine metrics team said it really well. Nobody really cares about WebAssembly. It's not about the WebAssembly. It's not. It's about what adopting this technology and workflow does for me. That's what I care about, is on the other side of it. And it's about contract-driven development, and it's about componentizing my code so it's more maintainable. Those are the things that really pay the long-term dividends here. And we need to just keep re-emphasizing and restating that over and over and over again. So it's not stupid, it's not slow, and it does bear repeating over and over and over again, because it's a lot of people are going to need to get this wave over and over again. There's roughly 30 million developers, depending on whose numbers you believe, and that's 30 million people that need to hear that.
I think it's pretty it's pretty incredible, Roman, to see, because WRPC in the wasmCloud community may have kind of come out of nowhere as we were pushing to 1.0 and redoing the way that we do RPC to be more components native. So the fact that this is another reference implementation of the way WRPC does component model value encoding, I think that this is really awesome to show this working in more than just Rust and in more than just the wasmCloud context, foreshadowing. But the fact that this can be something that the value encoding proposal can go upstream and we can implement it in multiple languages, like the possibilities for tooling and integration here is really huge. I mean, you can imagine like this specific example that Roman showed is not wasmCloud specific. It's not even WebAssembly specific, right? He's running a Go binary. So this is not the way that the framework that wasmCloud is using for its RPC. It also has great potential to interact with things outside of the WebAssembly ecosystem as well. Further, I think that really furthers our whole idea of like bridging to the future in the proverbial way, which is really cool.
Yeah, absolutely. In fact, talking about the second reference implementation, I was so surprised that it just worked. When I did the Go implementation and I was constantly testing it against the Rust one, and it just worked. I didn't even need to fix any bugs in the Rust one, so I was still looking for bugs. I still I gotta find it. There's supposed to be something there. But yeah, and there's now also somebody also started implementing the encoding for wasm parser phrase. So it's going to be the third implementation then. It's also Rust, but yeah, but certainly like the format is getting very standard. Is very close to merge in the code model so.
Amazing. You heard it here, folks. WRPC, no bugs. Can't find them, can't reproduce them. It's full of the software. Roman, I'm sorry, I keep skipping the queue. I do have one other question because I know that there's a little bit of an older RFC in the wasmCloud repo around the actual way that you were doing the binary encoding or the value encoding. I think that was like you spitballed it as Wooby or whatever it was. Is there a place that people can find kind of the lower level details of how you're encoding things when it goes across I mean, I guess in this case, NATs or however?
Yeah, so encoding is defined in the component model specification PR in the PR, the component model specification repository. So that PR is very likely to get merged very soon, but for now it's still open, so I'm going to link it here. Let's see. So that's let's say 95% of the binary encoding. The only two other remaining things there is that we also support streams in future which are not yet in the specification. So so for now, that's I guess only in the source code. But I am planning on sort of like formally defining, let's say with RPC over NAT. So that is what we can certainly define as a protocol and pretty formalize. With RPC by itself, it's sort of it's hard to really say. There's not really much to define. It's not really a protocol in itself, right? We have WebAssembly over NAT as a protocol, but let's say if we used, Unix sockets to use with WebAssembly, you would probably have a different protocol, a very different protocol than the one we use for NATs. Maybe if you use Kafka, maybe that would be sort of similar to how we do it in NATs world, but this really depends on the transport. So with RPC can only define, I guess, like say the semantics of how a transfer should behave. In particular, the transfer should be the only requirement we have for transport is that it's a multiplex connection with multiple streams. So both client and server can simultaneously and concurrently stream data over multiple streams. Send data over multiple streams, right? And that's due to the fact that, for example, you might have, let's say, a stream of streams, for example, as a data type, you would need to have this nested data structure, which is like infinite in some sense. So yeah, that's basically the requirement.
Nice. Yeah. It seems like it, I'm I'm very glad to hear that the protocol has room or has the ability to work with things that people might not even do for the near future, like doing the stream of streams. Somebody's going to try to do that inevitably and be like, maybe. And so I'm glad it's there. Yeah, okay, great. I was working on our documentation or a small diagram the other day and pointing some arrows around Nat's pub sub over or using WRPC, and I wanted to find some link somewhere to point to around, we're not just publishing the what's the right way to say this? Like the data directly. There is an encoding protocol. There is a request reply schema there. So sounds like I can somewhat point for early or for interested parties at the component model PR, but a formal spec is in the works in the near future.
Yeah, that's correct.
Cool. All right, I've been monopolizing time. Do other folks have questions for Roman? All right, thank you, Roman. I believe I have the great honor of giving you the next demo. So, taking a look at the second thing in the agenda is the wasmCloud Golang Provider SDK. Now, if you all have been around for long enough, this may not be a totally new thing for you. We actually do have a repository in the wasmCloud organization called Provider SDK Go. And this was something that we used I think always kind of on an experimental level, but for making capability providers that are written in Go. And with Roman, or just backing up a little bit, what this includes is all of the logic to connect to NATs, accept data to be a capability provider, like when you instantiate and run it at runtime with wasmCloud. It includes the logic over the control interface to make sure you can receive links and you know what component you're linked to. And it also includes the RPC layer, which this is using WasmBus RPC. So we were serializing and packing like an invocation and sending that according to the old RPC protocol, the pre 1.0 protocol. Now that Roman has a really sweet POC, a really sweet implementation of WRPC in Go, it seemed like the perfect time to take a look at this provider SDK and see if we can get it updated. So I took a look. I'm not the most advanced gopher in the book, but I really enjoyed getting to work on this. And so I do have a draft PR out there that essentially pulls out the WasmBus RPC parts of the provider SDK and then updates some of the structures internally so that it matches 1.0 type protocols. And this is simple as defining structs, like what it expects to get from the host, and some of the things like updating the topic to not include the link name anymore, like really small changes. Honestly, shout out to Jordan, Jordan Rash, who I know wrote a lot of this provider SDK, and I know that Iceberg and Taction, two other contributors, really worked on this. So shout out to making a really nice base for me to work on. And I was actually able to so I always forget about light mode sharing until after I do it. I was able to take a Roman's example of WRPC and make just a couple of changes to turn it into a wasmCloud provider. So the original, let's see, I don't have the diff here, but the original main function of this provider essentially looked like running running this run function, which connects to NATs. And then you may have seen Roman in his demo, he served with a NATS client and a prefix. And that prefix is something that is arbitrary and can be changed. And for wasmCloud, what we actually use for that prefix is the lattice name and then the ID of the provider. So I set up just a little bit of pre-processing here, where we basically we create a new capability provider using the wasmCloud provider SDK. And then we create the WRPC prefix from the lattice and the provider key. Um, but this is all essentially I had to change in this binary to make this a wasmCloud capability provider. The requirements are actually pretty simple. And this library, which is the provider SDK, handles all the logic around when you receive a link, putting that in the right place, when you receive a health check request, sending back a health check response, things like that. So what you saw was Roman was demonstrating the HTTP and the key value server. So in order to set this up, why don't I go ahead and launch wasmCloud? Just do it wash up. And I have a simple app that I went ahead. I haven't deployed it yet, but I did define it. So let me deploy it and then get the manifest just to show you what it is. So this is our Rust HTTP key value counter app, right? So I'm loading a local component, which is just what I built from the wasmCloud example. I'm going to connect this component to a key value store that's connecting to Redis. And I'll accept HTTP requests at port 8080, and all that's defined here in line with the config. So if I curl this endpoint, we get hello from Rust. This came from Redis. Great. And if you actually take a look at the implementation of this code, what I do is use WASI key value to open a bucket in the store, which is just blank. This is what you do for all of your key value things. I'm going to set this key, which says hello from Rust. This came from the Redis store. And then I'll retrieve that. I'll retrieve that key from the bucket, right? And if we actually, thank you, Vim. If we take a look at Redis, take a look at what's here. I forget what it's called. I think it's /counter. Yeah, that's what we set it. We get /counter. We say hello from Rust. This came from Redis. Great. So simple key value counter app. I'm going to go ahead and change this just so that it looks a little bit more satisfying. Say hello from Go. This came from the in-memory store, right? Good old hard-coded string here, and build that component. And then what I can do is because because Wash doesn't have build capabilities for Go capability providers yet, because we didn't have it until like yesterday. This is essentially what I'm doing. So I just build the Go binary and then pack it into a provider archive. So that's key value mem nats part of GZ. And I have a WADM manifest here that is a different version, but all it does is it swaps out the capability provider for Redis for this built capability provider that's locally here on disk. So I can wash app deploy this manifest. And if we take a look at the inventory, I want to make sure that we take this key value Redis provider. So this was the one that was running before. I'll go ahead and stop it to expedite this whole process. We can take a look at the inventory again. We see that we have the key value Go provider loaded from disk. And looking at I believe this will show something fun, at least. Our wasmCloud log. Where is it? Maybe it didn't show up. That's okay. I don't really need it. I was just going to show a debug log from the provider. And if we take a look at our links, we can see that is all still defined well and good. I can stop my component because I built it from before. And if we curl it, we get hello from Go. This came from the in-memory store. So this actually connects to the Go capability provider. And that is now being stored in like the Go in-memory key value store. So this is the same contract, WASI key value, just a different implementation. And if we take a look at get counter or anything, just to show you that this is really in the different store. The Redis thing is still saying hello from Rust. So this was a pretty good exercise in hot swapping providers. It's been a little while since we've done it for a similar implementation, but I really wanted to show off that we were able to take essentially combine the RPC layer of the WRPC implementation and our logic to handle links and shutting down and connecting to NATs from the provider SDK, kind of all into one provider, and it works out of the box. So I think moving forward, what I'd like to do, what I'd like to do as we look at the provider SDK is actually bring the WRPC library as a dependency of this provider SDK. Because if we look at an example provider that is just blank, it's actually very simple. And this is the experience that I want for people who are writing Go providers to come in with. All you need to do when you run the provider is call this function provider.new. And then you have essentially options to override any of the handlers. So when you get a new link or when you want to, send a custom message in a health check, you can override that with a function. And then you call p.start, and this will run the capability provider loop to handle everything. So if you could just do this and make sure that the provider is next to a WIT directory where it'll generate all of its types and functions, that's all you need to do for writing Go providers. So looking forward, we do have working examples now of Go providers, which is really sweet. So I think turning this repo into a home for a couple different examples will be the key for folks who are looking to contribute providers in Go. So now we have Rust and Go. Pretty sweet. Sorry if I missed anything in the chat. Do folks have any questions on the Go providers?
That's huge. I didn't even know you had that working. I missed stand up today. That's what I get. Okay, awesome. Okay. What's left? What's not done?
So what I want to do is, instead of having the example provider be something that has to both run the WRPC library and run the provider SDK library, I think it makes sense for the provider SDK library to run the RPC layer for you. So turn the provider SDK into something that can also serve on WRPC, like without you having to do anything there. And then just examples. I think that building out an example or two is going to show us if there's any rough edges in the API, if there's anything better that we can do in terms of, I think we have an outdated logging library, like little small things with this provider SDK, and we should just get a couple into our examples folder in the wasmCloud monorepo, like under the Golang language.
Is there any reason I wouldn't pick to write something in Go, like other than I prefer writing in Go, let's say, is my favorite language? Is there trade-offs between doing it with Rust versus Go, or are they basically equivalent?
I can't think of any reason why one would be strictly better for a specific use case than the other. I think that all of the same regular benefits of like a Go versus Rust conversation make sense. One of the reasons why I've really wanted Go providers is that it's very easy with Go to create a static binary, especially with the net HTTP implementation being in a standard library and not something that uses uses OpenSSL. It can be really easy to fall into that trap where you end up depending on a dynamic link. But that's just a static versus dynamic linking conversation. I really think the biggest benefit is any Go library is now easier to access in the wasmCloud ecosystem in terms, like, if you're going to work with like a Kubernetes API. Actually, the Rust ones are pretty good for that. I don't know, pick something else. If you're going to work with an API that's more in the Tailscale, then boom, available in the provider SDK. It just comes down to developer preference. That's my opinion. Now Roman has his hand up, so we'll see if there's a better answer.
That's good. That's good answer. But so the only thing I wanted to mention is that a few things actually. So like the first, of course, that Go support is still not complete for within with RPC. So there's no invoking anything, but no generating bindings for clients, and there's also no signed ins, no flags, and all that. But apart from that, so once we have that, which should have pretty soon, then I think actually a really cool thing about the Go is that it has very good, well, Nats is written in Go, so naturally integration of Nats is really, really good. And so, for example, since I'm also writing some Go tests, right, for the BindGen, so like I actually was very happy in the way I could integrate like the Nats server directly into my tests. So I didn't actually need to depend on the Nats server binary, but rather I can just start, I can just link essentially right to this Nats package and just start the Nats server in my test. Like there's all the functionality already for testing with Nats in there. So that's definitely like from perspective of like quick iteration loop and just like no dependencies, just run cargo. Oh, sorry, Go test. Just run my test. That was really I really like that. That was really nice.
All right, folks. Well, Bailey, anything?
I just have platitudes, it's great. It's amazing. I'm very excited. Um, so how hard is it to add another language like what you just did here?
I can speak from the wasmCloud provider SDK side at least. I think Roman will have a good answer around what it takes to implement like WRPC in a different language. The high level thing, like the logic for being a capability provider isn't really that hard. There's really not that much that goes into it. It has just a couple of um the couple of hard requirements around being able to compile to some kind of executable, thank you, Apple, being able to connect to NATs and accept some data on standard in is really the hard parts now. Message pack encoding was a difficult requirement of a pre 0.82 provider, so just being able to work with JSON and base64 is really nice. So the level of effort to add this type of logic to a different language is not very high. Roman, do you feel like as far as the RPC side goes, this gets easier now that we have more reference implementations, or is it about the same?
Yeah, so for with RPC side, it sort of depends on this on the ecosystem. And in particular, I guess that like once you have the encoding set up, right? Once you have the encoding of the wire protocol, then it's not that difficult. Like, well, you have to have a bind gen most likely to generate bindings, but then once you have the implementation of the encoding, that's most of the work, right? The codec, right? Encoding, decoding. So the cool thing, say with Go, is that the unsigned int presentation is exactly the same as is provided by like binary package in Go. So I can just literally just do binary dot put uint and then get my variable size int just encoded, or at the same for reading it. Now, I'm not sure I can do the same with JavaScript, right? I actually it's been a while, but I feel like there's no unsized int support in the style library if there's one. Um, so basically, let's say once that PR goes through the component model, right, and perhaps there are more implementations of that wire protocol in different languages, then of course we could just reuse that functionality. Then that task becomes much simpler. But if you have to implement the whole codec yourself, from scratch with nothing to help you, it's depending on how familiar you are with binary protocols and all that, it may be either kind of a simple but a little tedious task, or just a difficult task. So I think that's the biggest chunk of it. But yeah, and so in terms of like the bindgen, it also depends on, I found that Rust and Go is sort of similar. So I was able to just take the Rust bindgen and like replace stuff by Go code. So the Go bindgen still sometimes spits out Rust code. That's being fixed. Yeah, but so I don't know. So I guess for like C-like, let's say C-like languages, I feel like that should be simple. But if it's something like Haskell, that should be probably quite difficult. Yeah.
Yeah, I do feel like Rust and Go covers a lot of our bases, at least to start. I know in the roadmap section, foreshadowing again, we talked about doing it for Go and then spiking on doing it for something like for a language like TypeScript, which is another language that we have good support for on the component side. Um, so that'll be good to look out for. All right, folks. Other questions on Go stuff?
Bailey, any Go providers you've got prioritized to maybe get started on first?
I think Tailscale is pretty cool, but that's a Jordan Rash special. He's done that before. A number of his Go providers that he's built, I think would be great to bring over. All of them added a lot of value, and the reason why we made them was very much, as Brooks put it, like, hey, there's a lot of libraries out there that are only supported in Go. And I mean, the Kate's ecosystem does have good Rust bindings, but let's be real, most of it's in Go. So I can think of 1,000,001 things that I want. But I don't have any necessarily prioritized over another. So I'd really love some community feedback on that.
Yeah, I think we could do really well with like a blog or a documentation page on essentially doing something similar to what I did with Roman's project, like turning an existing or wrapping an existing Go library or project in a to create a capability provider to expose that in a reusable way to components. Throw that on the documentation and blog pages. It would be great to have stack. All right. Well, I know that we got a couple more things to talk about today, so I think we can go ahead and move on. And then, if there's any more questions, obviously, you can happy to answer those in the Zoom or YouTube or Slack chat. So, taking a look at the rest of the agenda, we just had one more item on here, at least for the planned agenda, which is the Q2 roadmap review. Thank you all for being a part of the road mapping session that we had last week. So on the roadmap page in the wasmCloud or on the wasmCloud documentation site, we now have our Q2 roadmap, which includes our high level goals, which have been updated, which we updated since the last quarter around, of course, we keep our number one goal around providing a seamless developer experience for building, testing, and deploying WebAssembly components. But we've got a couple of very notable new issues and RFCs to watch out for. And everything that we brainstormed in the session on Excalidraw kind of reformatted into 3 columns. It is just a coincidence that it happens to expand really well to fit the length of this page. But everything is under the high level documentation features or improvements, which is what we are looking as wasmCloud maintainers and contributors to prioritize over the next 2 months. So you can take a look at all of these. Hey, there it is, Spike TypeScript in orange. But all of these, we have also, of course, this is just an image and will be hard to track, but we have also made sure that everything is updated on the GitHub project for the wasmCloud roadmap. So you can take a look at this under, it's our only project. But we have documentation, new feature, and improvement, just like the picture. And each of these are kind of grouped by the work stage. And feedback definitely welcome here. think this is really nice for tracking, but I'm not really sure how nice it is to look at for a long time. But I think we'll get to figure out how that works. So you can essentially scroll down this page and see, what we need to add more information to, what's ready for work. And I think as a community member, if you're looking to contribute to something that's pretty high value and on the roadmap, something in this ready for work section with a good first issue label is a perfect place to look. We have a couple of things that we are working on and in progress, and we have completed one thing at least, mostly for this ticket, but it's pretty good. So it's incompleted now, so that's great. So yeah, everybody's welcome to take a look at more things. Any issue that you file and make a part of the wasmCloud 1.1 roadmap milestone in GitHub will automatically show up on here. There are also bug fixes as well, but we only had one that was marked for this, and bug fixes don't really need to be on a milestone. Like we can just fix them. So I've hidden it for the default view, but obviously everybody's welcome to look. So I didn't really have anything extra that I wanted to share there regarding the roadmap, just that we essentially formalized the brainstorming session and got that in GitHub. So all good things. Any questions on that part?
Hey, Brooks, have you talked about what that smart release feature is? What is that?
I haven't really. If we have time at the end, I will go into it. Um, you know what? I'll do a 1 minute spiel. So basically, in the where is this? Not that. In the wasmCloud repository, we have a lot of different crates, and a lot of these crates kind of have interdependencies, and we use them to make wasmCloud and Wash modular and nice maintainable software. The hard part about doing this is when it comes time to actually release a new version of Wash. This is actually what the automatic tool has done, but this is essentially what maintainers would have to do as they get to releasing a new version of Wash. We would have to say, okay, what changes have gone into the repository? We use conventional commits, so we can take a look back and we know what's breaking and what's a patch bump and all of those things. But we need to say, okay, we need to release a new version of Wash, but a patch feature went into provider archive, so we need to bump that. And Wash lib had a minor change, so we need to bump that minor change. So we need to publish that. But before we can do that, we need to publish wasmCloud core because there was also a minor change there. And this is essentially the thought process that you would have to go through all the way down. And this can be lessened in, like, the impact of this can be lessened in a couple of different ways. Like continuously releasing as soon as you publish a new feature is one way, albeit a little scary. But there is also this really awesome project called Cargo Smart Release, which is kind of this is used by some big project called Git Oxide. But this also integrates with changelog or cargo changelog such that you can specify a crate in a workspace and it can automatically determine what dependencies of that crate need to bump. Do they need to bump patch, minor, or major versions? And then to release cargo publish them, create a Git tag, and create a Git release for all of them in the correct order. So this is a huge, important piece of getting to release a crate that depends on many different other crates. So this almost solved the entire problem for us immediately. There was one feature which I'm very proud of. Just a quick pat on the back for taking a look into this. I'm very happy to contribute this about bumping workspace dependencies, basically the way that we set everything up so that all of our crates have the same dependencies. So what we are doing now, what you can do now as a maintainer in the wasmCloud repo is you can come into this GitHub action and then run the workflow with a repository dispatch, like for Wash CLI. And then when you run this, it will generate a pull request with all the changes that need to happen. And then you can merge that and run this again with the release box checked. It's not perfect. I think there's more automation to be done here. I would actually love to work on a little bit of a blog for how this works and why, but the key thing here really is that this really helps our process to get patch and small features out with Wash and wasmCloud really quickly. So there's a couple of things to work out, which is why I have the two-step process. But I want to automate the entire thing here pretty soon. And I think that would be really nice as an example for people who are working in really large workspaces too, for how to quickly release everything. Okay, I gave more of a spiel than I meant to, but this has been something that's bothered me for quite a while around how complex it can be to just push out a new version of Wash. I want to make sure when somebody like Taylor writes something cool like Wash plugins, we can get that to you as quickly as possible. So glad to get that done. Right. Well, I know that we have about 5 minutes left, and it has come to my attention that we have a slide-in demo for the end of the community meeting. Lachlan, would you like to show off something that you've been working on?
Yeah, for sure. So I'm gonna just share. Yeah. Those of you who have been poking around in there recognize that it looks like this. There are a few differences currently, but this version of the washboard is actually running from the new updated Lattice client that I have written and mirrored functionality of from Wash. So what I've got now, I've spent the last week or so rewriting this Lattice client so that we actually have a way of doing almost everything that Wash can do as far as like interacting with the Lattice through this JavaScript library. So it can get all of the hosts and get list them and start them and stop them. Well, not start them, but it can stop them. Because obviously a JavaScript client in a browser doesn't have access to a machine to be able to start a host. But all of the standard things that you would be able to do in Wash with through Wash on the Lattice is now available to do through this Lattice client. And the plan is to be able to release this client onto NPM as a package that you can install on either a node service or in a client browser application and be able to do everything that you would be able to do, hopefully, through Wash as well in this client. So going through this process and building it out like this has sort of given me a bit of insight into how the API for both the control topics and also for the WATM API are structured and what sort of things we might want to add to that. So I've already got a few issues out there that I'm going to start looking into improving this API. It's not quite in a releasable state yet. I'm hoping to get that up this afternoon. But yeah, this is where we're at. Hopefully this is giving some people some more thoughts and experimentation things that you might want to start playing around with. But yeah, I know a couple of people had asked for the Lattice client, and this is it.
So what's next, Lachlan?
Yeah, there's a few things. There's some stuff we want to get into Washboard, so updating this, but also like making the React consumer of the client a little bit better. And then we'll release that into NPM so that people can use that to build their own API, or sorry, their own dashboards and things. I know one of the community members was looking at implementing it into implementing like wasmCloud functionality into a completely separate dashboard for their own system that they would like. Yeah, I don't recall what system they were trying to get it into, but this would enable that. So, yeah.
It's really awesome. I had some pretty not recursive, heretical, fun thoughts about what we could do with like a wit to bottom plus lattice client that's connected to NATs. So I'm excited to play with this. I think Yordis was really interested in this. I was trying to think back to that community call. So I'll tag him afterwards, make sure that he knows. All right, folks. Any other questions for Lachlan before we wrap up? All right, everyone. Well, thank you for coming to the community meeting this week. All super exciting stuff. Look at us go. It's not just Rust, it's Go and TypeScript and React. All fun stuff. All right, folks. So I look forward to seeing what everybody can build with this, and I think we'll see you next week for more fun demos and discussion.